NEC Article 110.14c addresses the approved methods for connecting to similar metals, specifically copper and aluminum, in electrical systems. This is particularly relevant in residential settings where older homes may be wired with aluminum conductors, and connections to devices like outlets and switches often require transitioning to copper. The primary concern when joining copper and aluminum is galvanic corrosion. Aluminum is more reactive than copper, and in the presence of moisture, an electrolytic reaction can occur, leading to the corrosion of the aluminum conductor. This corrosion increases resistance to the connection, generating heat, and potentially leading to fire hazards. Therefore, the NEC mandates specific methods and materials to mitigate this risk and ensure safe and reliable electrical connections. One approved method is the use of connectors listed and labeled for the specific purpose of joining copper and aluminum conductors. These connectors are designed to create a secure, corrosion-resistant connection that minimizes the potential for galvanic action. They typically employ a barrier compound, often a grease-like substance containing zinc particles that inhibits moisture and prevents direct contact between the dissimilar metals. This compound also helps to break down any existing aluminum oxide on the conductor surface, improving conductivity. These connectors are commonly referred to as AL/CU connectors or CO/ALR connectors, where CO/ALR stands for copper/aluminum revised. It is crucial to select connectors that are specifically marked with either AL/CU or CO/ALR to ensure they are suitable for joining copper and aluminum. Standard wire connectors that are only marked for copper are not permitted for this application. Another approved method involves the use of a terminal block or a similar device that provides separate terminals for copper and aluminum conductors. These terminal blocks are designed to maintain physical separation between the dissimilar metals, preventing direct contact and minimizing the potential for galvanic corrosion. The terminals are typically made of a material that is compatible with both copper and aluminum, such as tin-plated aluminum. When using terminal blocks, it is essential to ensure that the conductors are properly tightened to the specified torque to create a secure and reliable connection. Improperly tightened connections can lead to increased resistance, heat generation, and potential failure. A third approved method is the use of a pigtail consisting of a short length of copper conductor that is joined to the aluminum conductor using a listed and labeled connector. The copper pigtail then connects to the device terminal. This method effectively isolates the aluminum conductor from the device terminal, preventing direct contact and minimizing the risk of corrosion. The pigtail must be sized appropriately for the circuit and capacity and must be installed in accordance with the connector manufacturer's instructions. In addition to selecting the appropriate connectors and methods, proper installation techniques are crucial for ensuring safe and reliable connections. Firstly, always to energize the circuit before working on any electrical connections. This is a fundamental safety precaution that helps to prevent electrical shock. Secondly, thoroughly clean the aluminum conductor to remove any dirt, corrosion, or oxidation. A wire brush or a specialized cleaning compound can be used for this purpose. Removing the oxide layer is essential for establishing a good electrical connection. Thirdly, apply an antioxidant compound to the aluminum conductor before making the connection. This compound helps to prevent further oxidation and improves conductivity. The antioxidant compound should be specifically designed for use with aluminum conductors and should be applied in accordance with the manufacturer's instructions. Fourthly, carefully tighten the connector to the specified torque using a calibrated torque wrench. Over-tightening can damage the conductor or the connector, while under-tightening can result in a loose connection. The torque specifications are typically provided by the connector manufacturer. Fifthly, properly insulate the connection using electrical tape or heat shrink tubing. This helps to prevent accidental contact with live conductors and protects the connection from moisture and other environmental factors. When working with aluminum wiring, it is also important to inspect the existing wiring for signs of damage or deterioration. Aluminum wiring is more susceptible to damage from overheating and corrosion than copper wiring. Look for signs of discoloration, cracking, or pitting on the conductor insulation. If any damage is found, the wiring should be repaired or replaced by a qualified electrician. It is also advisable to have the electrical system inspected by a qualified electrician to identify any potential problems and ensure that the wiring is safe and up to code. Furthermore, it's critical to understand that not all devices are rated for use with aluminum wiring. Many older devices were designed solely for use with copper conductors and may not be compatible with aluminum. Attempting to connect aluminum wiring to these devices can create a hazardous situation. When replacing devices in a home wired with aluminum, it's important to choose devices that are specifically listed and labeled for use with aluminum conductors, or to use one of the approved pigtailing methods described earlier. It is essential to follow the manufacturer's instructions for installing these devices to ensure a safe and reliable connection. The NEC provides specific requirements for the identification and marking of conductors. Aluminum conductors are typically identified by their silver or grey color. They may also be marked with the letters AL or aluminum on the conductor insulation. This helps to differentiate aluminum conductors from copper conductors, which are typically copper-colored. When working with aluminum wiring, it is important to be aware of these markings to ensure that the correct connectors and methods are used. The NEC also addresses the ampacity of aluminum conductors. Aluminum conductors have a lower ampacity than copper conductors of the same size. This means that an aluminum conductor can carry less current than a copper conductor without overheating. When replacing copper conductors with aluminum conductors, it is important to increase the size of the aluminum conductor to compensate for the lower ampacity. The NEC provides tables that specify the ampacity of different sizes of aluminum conductors. For example, NEC Table 310.15b16 provides ampacity ratings for conductors rated 0 to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in a raceway or cable or earth. The specific table used will depend on the type of wiring and the installation conditions. In addition to the requirements for connecting copper and aluminum conductors, the NEC also addresses the maintenance of aluminum wiring systems. Aluminum wiring connections should be periodically inspected to ensure that they are still secure and corrosion-free. If any signs of corrosion or loosening are found, the connections should be cleaned and retightened or replaced. Regular maintenance can help to prevent problems and ensure the long-term reliability of the electrical system. When performing electrical work, it is always important to comply with all applicable codes and regulations. The NEC is a widely adopted code that provides minimum safety standards for electrical installations. However, local jurisdictions may have additional requirements that must be followed. It is important to check with the local electrical inspector to determine the specific requirements in your area. Working with aluminum wiring can be challenging, and it is important to have the necessary knowledge and skills to perform the work safely. If you are not comfortable working with aluminum wiring, it is best to hire a qualified electrician to do the work. A qualified electrician will have the experience and training to ensure that the wiring is installed properly and safely. In summary, NEC Article 110.14c provides guidance on the approved methods for connecting copper and aluminum conductors. Firstly, use connectors listed and labeled for AL/CU or CO/ALR applications. Secondly, utilize terminal blocks with separate terminals for each metal. Thirdly, employ copper pigtails joined with approved connectors. Proper installation techniques, including cleaning conductors, applying antioxidant compounds, and tightening to specified torque, are critical. Always comply with the NEC and local regulations. When in doubt, consult a qualified electrician. Understanding these principles ensures safe and compliant electrical connections when dealing with aluminum wiring in residential or other applications. Remember that electrical safety is paramount, and following the NEC guidelines helps minimize the risk of fire and electrical hazards.